we have a solvent A, say for example, right? This is solvent. Will there be some vapor here at any time? Any time there can be some vapor. Suppose there is an equilibrium between these two. What does that mean? Equilibrium between these two. Meaning equilibrium between these two. If there has to be an equilibrium, this should be closed also. In a closed container only there can be an equilibrium. What is the meaning of this? There is an equilibrium between these two. What it means is, there are two processes taking place here. One is evaporation and other is condensation. Suppose rate of evaporation is equal to rate of condensation. Rate of evaporation is equal to rate of condensation. There will not be any change in the vapor pressure after that equilibrium is established. It will remain constant. At that moment, if we find out the pressure of this, we call it vapor pressure of the solvent P0A. Right? So P0A represents vapor pressure of pure solvent. Now what you do is, you add a solute which is non-volatile. What does that mean, non-volatile? Something which does not evaporate. Sodium chloride is a non-volatile solute. Sugar is a non-volatile solute. So, suppose you add a non-volatile solute, let us represent that solute by B. So, B is inside the solvent now. It dissolves. Correct? What will happen to P0A now? Will it be more or will it be less? It will be less. Why less? Here vapor pressure initially was P0A, which represents vapor pressure of the pure solvent. Now we added some solute in it. When a solute is added, vapor pressure reduces. Why it reduces? Exactly. Because these solutes will occupy the surface. It will mask part of the surface. Your rate of evaporation will come down. Therefore, vapor pressure will also come down. Now we don't represent it the P0A, we represent it the P of A. Because P0A is vapor pressure of pure solvent. So what is P of A? Vapor pressure of solution. P of A is vapor pressure of solution. Right? Now, suppose you put a more solute, what will happen to P of A? It will mask more the surface. Vapor pressure will further come down. So, does it mean that P of A is directly proportional to the amount of solute we put? What Raoults found out is, P of A is found to be directly proportional to mole fraction of the solvent. Mole fraction of the solvent. When more solute is added, will the mole fraction of solvent come down? When more solute is added, will mole fraction of solvent come down? Mole fraction of solvent XA is equal to number of moles of solvent divided by number of moles of solvent plus number of moles of solute. Correct? Similarly, mole fraction of solute is equal to number of moles of solute divided by total number of moles of solvent. And so what Raoults found out is, vapor pressure of the solution is directly proportional to mole fraction of the solvent, XA. Therefore, P of A is equal to a constant which is found to be P0A into XA. Therefore, P of A is equal to P0A into 1 minus XB. Why XA is equal to 1 minus XB? Reason is XA plus XB is equal to 1. Sum of the mole fractions in any solution is equal to 1. XA is Na divided by Na plus Nb, and XB is equal to Nb divided by Na plus Nb. You can see this is equal to 1. That is why XA is taken as 1 minus XB. Right? So can we write this as P of A is equal to P0A minus P0A into XB, which can be written further as P0A XB is equal to P0A minus P of A. You know what a P0A is? P0A is vapor pressure of pure solvent. Vapor pressure of pure solvent. PA is vapor pressure of the solution. Out of these two, which is more? Obviously, P0A is more. When you put a non-volatile solute, vapor pressure actually decreases. Therefore, vapor pressure of solution is less than that of vapor pressure of pure solvent. So, this P0A minus PA can be represented or can be understood as lowering of vapor pressure of the solution. So, what is P0A minus PA? P0A minus PA is lowering of vapor pressure of solvent when a non-volatile solute is added. Is that right? So this is what you have seen. P0A minus PA is lowering of vapor pressure. And that is equal to, that is found to be what? P0A XB. So can we say P0A XB is the lowering of vapor pressure, P0A minus P of A, which means what is XB? P0A minus P of A divided by P0A. You already know P0A minus PA is lowering of vapor pressure. This is P0A minus PA, which is lowering of vapor pressure. You divided this with P0A, which is vapor pressure of pure solvent. So what is this called? P0A minus PA is called a relative lowering of vapor pressure. Relative lowering of vapor pressure. So what has been proved? Relative lowering of vapor pressure is mole fraction of the solute. Be careful here. XB is mole fraction of the solute. But we started out with, or Raoults law proved that P of A is proportional to XA, where P of A is vapor pressure of solution, which is equal to mole fraction of the solvent. Why is it mole fraction of solvent? Because only A is getting evaporated, B is not getting evaporated. Your vapor pressure will not depend on solute, it depends on the solvent. This is Raoults law, and this only is used for deriving other colligative properties also.